Now going to question number 12. This is a unique situation that we refer to as splitting an equation. This is maybe one of the easier versions of this question, but we're going to see some harder ones. This is something of interest to students who really want to pursue that top score. It's one of those scenarios that only comes up once in a while, but when it does, you need to know what I'm about to tell you here. So the scenario is called splitting an equation, singular. And these situations always involve linear expressions on both sides of an equal sign, kind of like we have here. These are both linear because they both have x only to the first power. Not to say that anytime you have linears on both sides of an equation, you should do this. But if you get to a lot of these and look for videos on this concept in the future, then you'll learn to identify the situation when it comes up. So we've got linears on both sides of an equal sign. When that happens, you're going to split the equation. In other words, you're going to set each of the left and the right sides equal to y. Here, that would look like this. Y equals this thing, and y equals this thing. And from there, what happens is it becomes another common SAT situation, which is a little more straightforward. Now, before we get into that, let's just talk about why we did that. The logic is that if we had to find an intersection, what we're supposed to do is set the two equations equal to one another. So the opposite must be true. If we see an equal sign with two things on both sides, in theory, we can imagine that what we're seeing is an expression of an intersection, and we can take it back apart to figure out what were the two functions that must have intersected. And if they're lines, then what we're also talking about is the three ways two lines can interact. They can hit once, never, or all the time based on what's happening with their slopes and y-intercepts. One solution, no solutions, or infinite solutions. So when we're doing it here, we need to simplify. Y equals 150x minus 90. And here, y equals negative 90 plus 150x. If we just reverse the terms here, we'll have 150x minus 90. So we have one solution if our slopes are different. That's why they're hitting, because the slopes are different and they're tilted in different directions. We'll have zero solutions if the slopes are the same and the y-intercepts are different. That's another way to describe something that's parallel. And infinite solutions if the slopes and the y-intercepts are both identical. Everything's identical because they have the same location. And so here, that's what we have. We have infinite solutions because the two slopes are both 150. The two y-intercepts are both negative 90. So how many solutions are there to this situation? Infinitely many. And so the answer here is C.